From thousands of kilometers up, we get to see our planet for what it is, this living, breathing sphere of blue, green, and white. For decades, satellites have been our eyes in the sky, right? Giving us this incredible view of our own home. But here's the thing, are we really seeing the full picture? I mean, we have more data about Earth than at any point in history, but all that data comes with a huge challenge. The question isn't just about looking anymore, it's about understanding. How well can our tech really interpret the incredibly complex tapestry of life and land down below? And a big part of the problem, maybe surprisingly, starts with the very thing that lets us see in the first place: light. You see, our traditional satellites mostly just measure the light that reflects off the Earth's surface. And while that's been unbelievably useful, it also has some pretty serious blind spots. This is where we run into a problem called spectral confusion. So take a look. On the left, a satellite sees a city. On the right, it sees a rocky landscape. Well, to that satellite, the light bouncing off an asphalt road can look almost identical to the light coming from bare, rocky ground. They are what we call spectrally similar, and this creates a massive headache if you're trying to accurately map our world. And this is the result. We end up with these messy, unreliable maps that are filled with this salt and pepper noise. And this isn't just a technical glitch. This kind of confusion gets in the way of critical decisions. I mean, how are you supposed to plan for city growth or coordinate disaster relief when your map can't reliably tell a building from a boulder? We just have to see more clearly. So, how do we solve this? Well, a new way of doing remote sensing is starting to emerge. It's one that doesn't just look at light, but actually learns the very essence of a place. And it's all powered by a new kind of artificial intelligence. Okay, so at the heart of this whole revolution is something called a foundation model. Now, unlike the old AI models that were built to do just one specific thing, like, say, only identify forests, a foundation model is trained on an enormous, diverse data set. The goal is for it to gain a general, adaptable understanding of the world. In this case, the Earth's surface itself. So how does it actually work? Well, the model ingests a full year's worth of observations for every single location on the planet. It's not just looking at one picture. It's analyzing data from optical satellites, from radar that can literally see through clouds, and even climate data. This element of time is so important because it lets the AI learn the unique rhythm of each place as it changes through the seasons. Now, after processing this unbelievable stream of information, we're talking all the seasons, all the sensors, all the changes, the AI does something incredible. It compresses it all down into just 64 numbers, a 64-dimensional vector for every 10-meter patch of Earth. Just think about that for a second. A whole year of data from all these different sources distilled into a handful of numbers. These 64 numbers basically act as a unique digital fingerprint. It's so much more than just a picture. It's this rich description that captures a location's texture, its context, its patterns, and its rhythm over the course of a year. You could almost think of it as the digital DNA of a place. So with this new fingerprint for every single location, the potential to remap our world becomes, well, pretty extraordinary. The results aren't just a small improvement. They are a giant leap forward in our ability to really understand and manage our planet. Remember that noisy, confusing map from before? Just look at the difference now. On the left, you've got that classic salt and pepper mess from traditional mapping. But on the right, the map generated using these AI fingerprints or embeddings is clean, it's coherent, and it is incredibly precise. The AI cuts right through that spectral confusion because it understands context, not just color. And the numbers totally back this up. A study in Ghana's Greater Accra region, which is a really complex and rapidly growing urban area, showed this new method hit a stunning 98% overall accuracy. This is an absolute game changer for understanding and managing urban growth, especially in developing countries where accurate, up-to-date maps are so desperately needed. This new vision also lets us see details that were pretty much hidden before. We can now detect small individual objects like brick kilns from space, or we can map the tree canopy in a city, not just as a green blob, but as individual clusters of trees. This level of detail changes everything, from environmental enforcement to urban forestry. But, and this is a big but, like any powerful new technology, this new vision isn't perfect. To truly get a handle on its potential, we also have to understand its breaking points. In fact, recent research puts it pretty bluntly. Despite incredible performance in tests, these models can really struggle when they're faced with the messiness of the real world. A perfect score in the lab doesn't always mean perfect performance out in the field, and that can have serious consequences when we start relying on these models for critical decisions. So, what trips them up? Well, sometimes it's something as simple as clouds getting in the way. Other times, the model gets confused by landscapes that are totally unfamiliar to what it was trained on. That's a problem called spatial generalization. It can also be thrown off by unexpected seasonal changes or even by human ambiguity in how we define a forest or a city in different parts of the world. All of this brings us to a really pivotal moment. We are standing right at the edge of a new frontier in how we perceive our planet. And the challenge is no longer just about seeing, but about understanding and then acting on what we see. You see, for decades, the main challenge was just getting enough good, clear data. We've we've largely solved that. Now the challenge is something else entirely. It's not about a scarcity of data anymore, but about the wisdom and the responsibility of applying this powerful new vision. It's almost like we've been given a new sense, and now we have to learn how to use it. So here we are. We've created an AI that can generate an intelligent fingerprint for nearly every single place on Earth, and it's revealing patterns we've never seen before. This gives us an incredible power to monitor, to manage, and to act. The final question, then, isn't about what we can see, but about what we will choose to do with this powerful new clarity.